all. This is one of the more challenging things that we do in term 1. So we've got a fair bit to get through in this video. So we're looking at factors, factor trees, lowest common multiple and highest common factor. These are a bit confusing, so we'll see how we get to the end. Alright, so first of all we need to know what a prime is. A prime is a number that has only two factors, one in itself, and the best example we always use is the number like 13. Okay, the only numbers that go evenly into 13 are 1 and 13, and there's no others, so that's what we call a prime number. It's quite handy to know the primes are 20. It's not overly important, but it's quite handy just to know them because they'll come up quite over and over again over the next few things that we're going to be doing. Alright, so often you'll be asked to use a factor tree to find the prime factors and express in index form. So we talked about indexes in the previous video. So this one here is what we're going to call a factor tree. So a factor tree works by this, where you would have, okay, that's two numbers that go evenly into 8. Well, let's use 2 times 4. Okay, so 2 is prime, so we can leave 2 there. 4 is not prime, so we have to break that one down again. 2 times 2, and again, they're prime. So to express that in index form, we would put 8, find the equal sign, equals 2, and then I'll use my little index here to make it myself. Set that one there, and 2 to the power of 3. Okay, so that's a factor tree, and we found the prime factors, 2, 2 and 2, which would be just, where am I? Got my little arrow. So here's all the things we want to use here. There's 2, 2 and 2 here, and then we've gone 8 equals 2 cubed. Okay, so it shouldn't be too bad. Let's have to do something a bit more challenging in the next one. Alright, this time we've got 36. Use a factor tree to find the prime factors and express in index form, and we're going to do 36. So if I go back to my pen, I have to write fairly small to fiddle this in. I'm going to use 4 times 9. You could also use 3 times 12. There's different ones that we could use. You'll still end up with the same prime factors, so it doesn't particularly matter. So in this one, neither 4 or 9 are prime. So this one I can do 2 times 2, and the 9 is going to be 3 times 3. So here we have all these are now prime. Okay, so now rather than go and type it out, I might just write this out with my hand. So if we go down the bottom down here, we're going to have 36 equals 2 squared times 3 squared. You can always check that by going, well, 2 times 2 is 4, 3 times 3 squared is 9, 4 times 9 is 36, and it should multiply up to the number and to see if you're correct. Alright, hope that makes sense. There's a few to practice if you need to practice at the end, but we'll keep moving forward. Alright, the next one is lowest common multiple. Lowest common multiple and highest common factor are often confused, but just remember the important part of this one is using the word here, okay, using the word multiple. So it tells us to multiply. So we know we're going to multiply. We're not looking for factors, highest common factor, we're looking for multiples. So in this one here, let's choose find the lowest common multiple of 5 and 15. Well, let's just put down 5. I usually say write down the first 5, and you can usually find it then. No, it doesn't always work. Sometimes it does. So let's put down the first 5 multiples: 5, 10, 15, 20, 25. Then we're going to write down the first 5 multiples of 15, 15, 30, 45, 60, 75. Okay, then we're going to have a look at, alright, let's find the lowest common multiple. Let's just change some colour here. I'm going to go to red. So here's one, here's the other one. So then to write that out, we would write I'm just going to put LCM today, CM of, let's state, of 5 and 15 equals 15. Alright, and done. Pretty straightforward. That, just remember the multiples, the only thing that's confusing, so we have to multiply times 1, times 2, times 3, and so on. That's a fairly easy example. There are some more challenging ones that we'll see in the examples at the end. And then you'll see this question will come up quite a bit. Use a factor tree to find the highest common factor of 18 and 24. Alright, so we can just go through and go 18 is 1 times 18, 2 times 9, 3 times 6, and so on. But sometimes it'll ask you to use a factor tree just so that we make sure we're using them well. So I'm going to do this one today. 18 is going to be 2 times 9. Okay, and then I'm going to go 3 times 3. So we've got it down to prime factors again, like we did in the prime factor tree. This one here then is going to be 24. Let's look at 24. I might choose something to just do 2 times 12 today. 2 times 6 and 2 and 3. Okay, so then I can start matching up my pairs. So let's just change my colour. I'll go to blue. Oops. So I'll go to green. Here we go. So I've got a 2 here and a 2 here. So I'm going to have to put it over here. So the HCF is 2 times, I've got a 3 here and a 3 there. Okay, so they're the only ones that match up. 3 doesn't match up to anything else, 2 doesn't match up to anything else, so the HCF of 18 and 24 is going to be 6. That's a bit confusing and takes a little bit of getting used to, so feel free to do some practices. Right, hope this makes sense. As always, come and have a chat to me if you're struggling with anything, and good luck.